Hey you guys, 3.4, composition of functions. We're going to look at a couple of different things. You can add functions together, subtract functions, multiply, divide, or you can take the composition of functions. This word problem sets up, it's talking about, you have the word problem is about, you're trying to figure out how much it's going to cost to heat your house. But the amount of the thermostat that you need is dependent on the temperature outside. So those two things are two separate functions. So C of T is the cost of heating a house, and T of D is the average daily temperature. Okay, so T is degrees Celsius and D is day of the year. For example, we could evaluate T at 5 to determine the average daily temperature on the 5th day of the year. Then we could evaluate the cost function at that temperature. But if you combine those two functions together, you would only have to do one thing. So we're going to go back and do some of the basics for this. All right, so here we're talking about just different, sorry you guys. So here we're talking about just different ways you can combine them. If you're adding them together, it's the same as writing it this way, just different ways to write things like we've already talked about. So many different ways to write things in math. We have interval notation and set notation. It's kind of the same thing, just two different ways to write something. So the first one is asking us to add these two functions together. So what I want to show you really quick is that I have this set up on Desmos. So I have f of g and I have, let's see here. What was the other one? G of x. I have f of x and I have g of x, okay? So 2x minus 3 is this red line. So the, if you can look down here, the y-intercept is -3. It's up 2 over 1. The blue is x plus 3, so the y-intercept is just regular 3, and its slope is just up 1 over 1. Okay, so two functions. Now, if you add them together, check out what's going to happen. So if you add them together, let's see if I can do this. Let's see if I can write this. Nope. Okay, if you add them together, you get 2x, son of a gun. Okay, 2x minus 3. Okay, and then I'm going to add plus, right? X plus 3. Okay, and so look what's happened. My new function, my green function, is the function that happens when I'm adding them together. So instead of the y-intercept being -3 or +3, the y-intercept 0, because I've added -3 and +3. Instead of the slope being either 2x or 1x, the slope is 3x. It's a lot steeper because I added 2x's and 3x's. So you can literally see that for a linear equation, it's pretty easy to see. When you add them together, what happens? Okay, so let's go back to what's happening. So all we have to do is just like I said, you can do it like 2x minus 3 plus x plus 3. And this is fairly simple. It's going to be 3x plus 0. Obviously, you don't need the plus 0 there. What happens if we subtract them? I'm going to reiterate for you guys, do not forget to distribute that negative. Okay, this is the difference here. Distribute here, we're subtracting x, but we are also 100% subtracting the 3. So what's going to happen is instead of 2x's, we're just going to have 1x. And then we have -3, but then we have another -3. So we're actually subtracting 6. So our slope is just going to be 1, but our y-intercept is going to be -6 for that one. F times g. So we're going to have to use the area model, right? Or you guys could just FOIL. You could do it in your head, but I know some of you are still struggling with this, but you're going to have to get good at it pretty quick, okay? So 2x minus 3 times x plus 3. When we multiply them together, we're obviously going to get a parabola. If we did it on Desmos, you would see it would turn into a parabola. So it's going to be 3x squared minus 3x plus 6x minus 9. So that ends up being 3x. Why did I do 3x there? 2x squared, duh. 2x squared plus 3x when I combine the x's, minus 9. Thank you if you were yelling at me to do that and I couldn't hear you here. Okay, so this one's going to be interesting. This is talking about finding its domain. You have to find the domain of each function before and the domain of the function afterwards. So both of these are linear, right? So we're okay with this. These can be the domain from negative infinity to positive infinity. But when we're dividing it, it turns it into a rational function, right? So our domain is only going to be from our composition of this function. So we put it wants the f function on top, so 2x minus 3 over x plus 3. We don't have to do anything else because I don't think I can simplify it in any way. The domain, and remember, going into this, the domain is negative infinity to positive infinity, but now x cannot be negative 3 because that's going to make this denominator explode, but it can be any other number, right? So it can be negative infinity. We always start with the lowest. Negative infinity all the way up to negative 3 cannot be negative 3 union negative 3 all the way to positive infinity. Same for the next one, except this time it's going to be g divided by f. So instead of negative 3 being, instead of negative 3 being our missing link, as it were, it is going to be, we're going to have to solve that domain for 0. So in my head, I'm adding 3 to the other side divided by, so negative 1.5 or negative, or positive, positive 3 over 2 is what it cannot be. So positive 1.5. So let's see, it's the same thing, negative infinity to 3 over 2 or 1.5 union 3 over 2 comma positive infinity. Okay, so make sure you get those. So your composition of functions. A composition of function literally means you're taking the output of one function and it becomes the input of another function. Okay, so write that in your own words. You evaluate, and it has these 2 steps for you. You evaluate the inside function using the input variable from the variable provided. So what we're doing now is going to be a lot easier because we're actually being given numbers for this. Eventually, if you remember from pre-calculus, we will get into just literally putting a function into another function. So let's just, it wants us to use these 2 functions and do f of g of 1. So f of g of 1 means that I'm going to take my f of x, but everywhere I see x, instead, I'm going to put g of x, right? Or this is exactly what I was saying. We don't want to get to this hard part first since we are having numbers. So I'm taking g of x and I'm making it 1. So if my input is 1 here, my output is going to be 2. So 2 becomes what I input into f. So 2 of 2 times 2 plus 1 is equal to 5. Again, I'm doing this all in my head, you guys, so please double check me if I make a mistake. All right, so what does this mean? This means f of g of 1 is equal to 5. Okay. I will do, and then it goes into what we do. I'll let you do the next one, the next number, and then we'll get into what I was originally saying. I was just skipping over to this last part. So if we don't have a number, here's what I want to get to, this one. F of g of x means that wherever I have in my f of x is 2x plus 1, right? But instead of x, I'm going to put the entire g of x, right? Instead of x right here, we have g of x. So instead of just x, I'm going to put 3 minus x. And I can simplify this, and I think they probably want you to, is going to be equal to 6 minus 2x plus 1, which is equal to negative 2x. What is that, plus 7? Oh, sorry, guys. Okay, so I want to see you do the same with g of f of x. So instead of taking the g and putting it where the x was in f of x, you're going to take the entire f of x and put it where the x was in g of x. So that was how you do it algebraically with the function. Now if we're actually looking at a table to evaluate it here, we want f of g of 3. So if I input 3 into g, right, my output is 2. So then you need to look at inputting 2 into f of x, which your output is 8. So f of g of 3 is the same as f of 2, which is 8. Okay, you can do it backwards. Now, the next part it wants you to do backwards. You take, and you're doing f of 3 first, right? So your output is 3. But then, so your output is 3, so your input is 3 again. So your output is 2. So g of f of 3 is the same as g of 3, which is 2. All right, so we're doing the same exact thing, except this time we're just using a graph. So evaluate f of g of 1. So where's my f of x? Oh, okay, so this is g of x, this is f of x. So in g, if I put in 1, my output is, I don't know, you guys, I can't tell, 3. So then I look at 3 over here, and my output is 4. So that's 4. So when we're finding the domain of a composition function, you first have to, and it has the little steps right here, but you first have to find the domain of both functions and then look at what you are actually doing. So in this one over here, in this example, finding the domain of a function, we are trying, hopefully I can get this video done before we run out of battery here. In our example, we want to do f of g. So our input is going to be g, or my input for f is going to be the output of g. So my input for f cannot be 1. So what we're doing down here is they are solving g of x for 1, okay? And they are saying, it looks like they just cross multiplied there. They are saying if I input, they're saying this. If I input 2 into g, the output is 1. Okay, so my domain for g cannot be 2. G of x cannot be 2. So that's exactly what it's saying down here. So when you're looking for the domain f of g, x cannot be 2/3, and this is what we originally figured out for g, right? But also, x cannot be equal to 2, because that makes it 1, and we can't input 1 into the other function. So here, decomposing a function is we're doing the opposite of composing a function. So we have f of x is the square root of 5 minus x. So it wants us to come up with a way where we could make g of h of x. So we're going to have something that is g of x. We are going to have something that is h of x. My dog's making funny noises. But the h of x is what is going to be input into the g of x. So what they came up with is g of x is the square root of x, and h of x is 5 minus x, because if I do g of h of x, I will get g of h of x, sorry you guys, I will get the square root of h of x, which is just 5 minus x. Okay. Suppose f of x gives miles that can be driven in x hours, and g of y gives the gallons of gas used in driving y miles. Which of these expressions is meaningful? So the question is, my output for g is gallons of gas. Am I going to take gallons of gas and put that in an equation that gives me the number of miles that can be driven in x hours? Or am I going to take the number of miles that can be driven in x hours Are we still recording? You guys, I'm so sorry. My battery died in the middle of this. Suppose f of x, blah, blah, blah. We already talked about that. Which of these expressions is meaningful? That we are going to input the number of gallons and figure out how many we can drive. Like, I think that's the one. I don't think we would input in the number of miles that we can drive and then be able to get the number of gallons of gas. So I think it's definitely this first one here.